Yo everybody, right, 2023 paper, AS Unit 2 mechanics stuff. This is the last question. It's either going to be a velocity time graph or displacement time graph. This year it's velocity. So before you even look at anything, just think about what that graph is telling us. The graph is telling us it's moving away from the origin, speeding up. And it's still moving away from the origin, but slowing down. There it changes direction. And now it's moving back towards the origin, speeding up, and back towards the origin, slowing down. Okay, very different interpretation if that was displacement up there. So try and understand that first before we look at the question in detail. Here we go. Find the acceleration of the particle when t equals 1. Now t equals 1 is about there. And this is a straight line. So that means it's got a constant gradient. So from the start to 4 seconds, the acceleration is the same. There's many ways to do it, right? But if it's constant acceleration, my brain goes cheeky through that. Constant acceleration. Let's see what we know. We know the final velocity is 5. We know the initial velocity is 2. We know the time taken to get there was 4. So I'm going to use v equals u plus at, chuck it all in, rearrange it, and I've got the acceleration is 3/4 or 0.75 meters per second squared. Happy days. Right, then they want to know the distance travelled from 0 to 12. So the distance travelled is the area under a velocity time graph. So split it up. That's a trapezium. Add up the parallel sides, 2 and 5, half it, and then times by the height between them. This here is a triangle, half the base, so that's 8, half of that is 4, times the height. Right? So chuck those numbers in, nice and easy really for 2 marks, and you get 34 meters. Right, happy days. Okay, now it gets a little bit more complex, obviously, it's bound to. When t equals 22, so here, the displacement of the particle from the origin A is 14 meters. Determine the value of v. You need to work out this here. Now this takes a bit of thinking to get the interpretation right so you know exactly what you are trying to work out. And as I've written here, displacement is the key. We know that from 0 to 12, it travelled 34 meters away from the origin. And at t equals 22, it was 14 meters away from the origin. So if you think about that, that means this distance travelled here, in which is coming back towards the origin, must be 20 meters. Right? This bit has gone 34 meters away, and when it gets here, it's 14 meters away from the origin. So this bit must have represented 20 meters towards the origin. Okay, if you've understood that, the mathematics is easy from this point. That means the area of this triangle is 20. The length, or the base, think of it as the base, is 10. Half the base times the height is 20. Half the base, half 10 is 5. 5 times something is 20. This something, this height here, must be 4. Okay? But of course, it'll be negative 4 because it's traveling in the opposite direction to the original velocity. It's coming back towards the origin. So v was minus 4. And the key to that wasn't the maths really, it was the interpretation of the graph. And then finally, write down the time interval in which it's moving towards A and speed is increasing. So the only time it's moving towards A is between 12 and 22. Light's just gone off. And the point between here where the speed is increasing is between 12 and 18. This bit here, look, the speed is decreasing. And just in case you want to think about it a bit more, I've written them all down there. So from 0 to 4, it's moving away from A and speeding up. From 4 to 12, it's still moving away from A but slowing down. Velocity is negative. From 12 to 18, it's moving towards A and speeding up. And from 18 to 22, it's also moving towards A, but slowing down, right? If you can understand how that velocity time graph works, that'll hold you in good stead. So that's the paper. Awesome. I hope you got full marks, and I'm sure you did.